Hi, everybody. Today, you can see the title up on that screen. We're going to deal with some powers and our power laws. If I had to rank, most important lessons throughout the year, I think I would probably fit today in top 5. Like I would argue easily top 5. That what we're going to do is we're going to lay the groundwork for where we go with a lot of our algebra coming up. So we're going to learn some properties today, and I'm going to expect you by the time we walk into class the next time to be really automatic with all the stuff that we covered today. So to be automatic with that, we're going to kind of take a half a step back. We've dealt with a little bit of an introduction and a review of our powers. You see at the top of the screen, we just have another breakdown about the components of a power. Remember, there's always a base, there's always an exponent, and all a power represents is repeated multiplication. That what I want to do is I want to spend just a quick moment taking that half step back and making sure that we have all of those other issues, all that theory about powers taken care of. So you see 6 problems on your screen right now. I want you to go as fast as you can through those 6 problems, and we're going to make sure that we have all of our theory nailed down from previous days. Okay, pause the video now, work your way through, you should be good. Okay, we're back. So, a few things for us. We take a look at problem 1, and this should all just be confirmation for us. So as you worked your way through problem 1, you notice you had a little bed mass question. You had powers, so therefore exponents, and addition, and you know that we have to deal with exponents before addition. And so therefore, when you worked your way through, you calculated 4 squared and got 16, and you calculated 2 cubed, so 2 times 2 times 2. And now we finished off our last operation. And there is our value of our expression evaluated, or written in standard form. You write it like a number. So we got down to 24, we should have been good. Okay, I threw question B at you, 8 to the 5th. 8 to the 5th is not a power that I would expect you to know off the top of your head. And so 8 to the 5th would be a calculator issue for us. So that's just about us making sure that we were fine to push buttons on our calculator, identify an exponent button, and we should get down to 32,768. If you didn't get that, then we want to check our keying sequence on our calculator. Everything else that you see on the screen, we should be able to do without a calculator. So we work our way through question C. We see we have negative 2 to the 4th. I have a even exponent on a negative base. And so I know all my negatives will pair up. My answer has to be positive. And I have memorized that 2 to the 4th is 16. We come in and we deal with D. You notice in question D, we have an odd exponent on a negative base. And that tells me then that my answer will be negative. So I calculate 3 cubed. And there's my 27. You have that memorized. Now we walk into E, and you notice that you have a single power that it's raised to an exponent. It's just that the base of that power happens to be a fraction. And so we know then that what we can do is apply that exponent to all parts of the base. The base is one term, it's one fraction. We apply it to everything. And therefore, we can just jump straight to a 2 cubed, which is 8, over 3 cubed, which is 27, and we are fully simplified. Now we jump into F. F gives us a power that's a little bit higher than what we need to have memorized. We recognize an even exponent on a negative base, and therefore we're going to have a positive value. I know 2 to the 5th off by heart is 32, so if I double 32 to get up to 2 to the 6th, I get 64 and we're good. And as you guys start to work through, pretty soon you'll just start to memorize the 2 to the 6th is 64. Okay, for those 6 questions, I hope that everything matched up. You can tell we took a step back a little bit to make sure that we're solid with our review. We're going to still work our way through that review a little bit more. Okay, what you see on the screen now, it's really like 4 problems, but I'll call it 3 of them, all under the heading of question 2, write as a power. So what I want you to do is I want you to take the standard number 27 and write it as a power. Write B, 9 as a power. Write C, 81 as a power, and so on. The only thing I'm going to say is if you said 27 to the exponent 1, I want to slap you virtually. That would not be considered a power because when there is an exponent 1, we don't have to write it. You're actually putting it in standard form. So be very careful on that. Okay, the next question to that, write which of these could be written as a base of -3. So we'll kind of get to both parts. Feel free to answer both parts or feel free to stop and come back when you're done C. Okay, pause it now. Okay, we're back. So I am hoping that when you guys took a look at those, 27 we recognize as 3 cubed. B, we would recognize 9 as 3 squared. And C, 3 to the 4th. Now, I've made some comments about what we've memorized. You should know 2 to the 5th off by heart. And every power of 2 that comes before that. That's what we want to work to. So if right now 2 cubed was the highest one that you had memorized, then we work to double 2 cubed. So double 8 is 16. Then we double again 30. Okay, 32. And I'm going to start to drill that in. You want to know up to 3 to the 4th off the top of your head. Automatic, 81. You want to know up to 4 cubed off the top of your head. You want to know 5 cubed off the top of your head. Everything after that, if you know your squareds, then I think we're doing great. That's what we want to work towards in terms of what we know, automatic reflex answer. Okay, let's take a look at that last question now. Which of these could be written as a base of -3? And I would hope that we would have been pretty solid to be able to then go, well, if I wrote that as a base of -3, I would need to have an even exponent to change my answer to a positive. So only these values that had even exponents, those powers, could be written as a base -3. Now, hopefully we came up with that and we were feeling pretty solid. The other part that I do want to address is I would have had a bunch of people in question C that would have maybe said 9 squared, because 9 squared gives you 81. So I want to make sure that we're good with all of those. Okay, there's our review. Now I want to jump into the topic for today. So what you see on your screen now is a little bit of a table. It's going to follow along with our lesson. If you're doing this on blank paper as opposed to a printed lesson, then just fill in the slots. I don't know if I would spend the time really going through and copying out the full table. It is very important, though, to know the instructions at the top of the screen. The difference between evaluating something versus writing it in expanded form versus simplifying it or writing it as a single power. Those things are important. So we want to make sure that we're good on the difference. So let's walk through the top row of that table just so that we're good on how to fill in the table. Okay, the first column asks me to evaluate. So I'm going to put that in purple. So I need to evaluate. Evaluate means calculate. So I can go through then and I can say, okay, well, 2 to the 5th is a 32, and I don't know why I wrote that as 3 squared. And then I need to multiply that by, well, 2 cubed is an 8. So I need to calculate 32 times 8. Well, 30 times 8 is 240, and 2 times 8 is 16. So 240 and 16, 256. And there we go. Okay, now I go to the middle column. Write in expanded form. Okay, well, expanded means I write out my repeated multiplication. So I have my 2 to the 5th, which is going to be 5 2s separated by multiply, times now 3 2s separated by multiply. Okay, at the end now in blue, it asks me to write that as a single power. Well, if I look back at that middle column, I notice that all my operations are multiply. And it never matters what order I multiply in. So really, these brackets, I didn't have to write. I could have put them in there, but they're not needed. Now, I'm going to put them back in, though, just so we can really see our 2 to the 5th times 2 cubed. But I recognize, though, they don't matter. That really what I have then is 1, 2, 3, 4, 5, 6, 7, 8. 8 2s all separated by multiply. Well, how do I write 8 2s separated by multiply? I have 2 to the 8th. Okay, there's how I fill in my table. What I would like you to do is to work through this next row. And then if you can get to the point where you can maybe see a pattern, what I want us to do is to try to apply that pattern. Even after just seeing 2 examples, how could we take that expression and vault over everything else and get to that last simplified form? That's your job. So can you fill in the middle row and then try to pattern it out so you could now take this expression that I've circled in green and jump straight to a simplified form. Okay, I want you to pause the video and give it a shot now. Okay, we're back. So I'm just going to get rid of all that green. Okay, I can quickly go through then the evaluated form, expanded form, and simplified form. So hopefully what we had is a 3 cubed, which was 27, times a 3 squared, which is 9. Now I have to calculate. Okay, that one might be a little uglier. So maybe I go, okay, 20 times 9 is 180. And then 7 times 9 is 63. So if I take my 180 and my 63, then there is a 243. Okay, now I take my expanded form. Well, my expanded form says take 3 3s and multiply that by 2 3s. There's my expanded form. And now if I look at that, I really have 5 of the base 3 separated by multiply. Okay, that's what our middle row should look like. And now we're trying to pattern it out to be able to anticipate, can I take 5 to the 4th times 5 to the 6th and skip over evaluating it and skip over expanding it? Could we just simplify it in one step? So as I'm erasing this, you're looking for a pattern. If it's taking you a little bit to see the pattern, then pause the video. We're going to go straight on with our pattern. So what I'm hoping that you guys got down to was something that looked like that. And if you did, then you have our pattern. What I just want us to do is to get down what that pattern is in formal terms. So what you see below that table is a statement that's got a bunch of blanks in it. We're going to fill in those blanks. So the first thing that I want to kind of bring to your attention, and I'm going to highlight it in green. In all 3 of those cases, we were doing the same operation. So what did we do? We were multiplying those powers. So when we multiplied powers, okay, I'm going to get rid of that highlight. And now what I want us to notice is what was the same about each one of those questions other than the multiplying. Well, if you take a look in question, the first row, it was a power base 2 and a power base 2. In the middle row, it was a power base 3 and a power base 3. In the last row, it was a power base 5 and a power base 5. That means we were multiplying powers with the same base. Okay, well, if we're multiplying powers with the same base, then what happened? Well, if we look at our shortcut, I had a 2 to the 5th times a 2 cubed in the top row, and that became a 2 to the 8th. A 3 cubed times a 3 squared became 3 to the 5th. A 5 to the 4th to the 5 to the 6th became a 5 to the 10th. That maybe we can see our pattern. What did we really do? We add the exponents. And sometimes, maybe the most important point, the base stays the same. And you're going to hear me say that with some oomph today. That might be the most important part for us. So there is our law of exponents. And it's the first law. Not that there's a hierarchy to the laws, but it's the first one we've addressed. That when multiplying powers with the same base, we add the exponents and the base stays the same. Okay, I think we should be good on how we can pattern out some things. And I think because we were able to look at that expanded form, we could really see why that was the case. Okay, I want to tackle a few problems, so here we go. Okay, take a look at the 5 problems you have up on the screen, and I would like you to go as fast as you can go through those 5 problems. And I mean, I want you to go quick. So you race through those 5 problems as fast as you can go. I want you to simplify each. Pause the video now. We'll meet up in the end. Okay, we should be good. So I'm just going to go through and make sure that we were all good. I have a power base 8 times a power base 8, so I know my answer is a power base 8 when I simplify. 10 and 5 are my 2 exponents. When multiplying powers to the same base, I add those exponents. There we go. Okay, I should be able to go super fast. Make sure that you have brackets on your base. Otherwise, that means something very different. C, multiplying powers of the same base, add the exponents, base stays the same. D, multiplying powers of the same base, add the exponents, base stays the same. If you don't have brackets around your 1/2, you are incorrect. And we get down to E, and we got good old omega in E. So our answer is going to be omega, because the base doesn't change, to an exponent of 50. Okay, hopefully that stuff matches up. We were all good on those 5. And now what I want to do is I want to change gears a little bit. So we're going to go back to working with the table. It's going to look a little different, but I think we can maybe see where we're going for the rest of today. So let's look at the table that we have in front of us. You'll notice that our titles are all the same. So we need to be able to go through, evaluate. We then need to be able to write it in expanded form. And finally, we need to be able to write it as a single power. You'll notice, though, that the expressions are a little different as we work our way down. So what I would like you to do is to go through and do the exact same thing as we did before, but we're going to take it in its bits. So let's take a look at the evaluate for the top row, and what I'd like you to do is simply fill in the evaluate cell of that table. Okay, top row only, 2 to the 5th divided by 2 cubed. Let's evaluate that. Pause the video now. Okay, we're back. And so we calculate 2 to the 5th, which was 32. We calculate 2 to the 8th. That is 8. Sorry, 2 cubed. That is 8. And now when we calculate 32 divided by 8, we get 4. Nice. Okay, now we need to write that in expanded form. I think we should be good to write that in expanded form. So I want you to pause the video now and write it in expanded form. Okay, we're back. So on the top of my fraction line, I need to have 5 2's separated by multiply. And on the bottom of my fraction line, I need to have 3 2's separated by multiply. There we go, we're in expanded form. Now, in the last row, we're going to do this one together on the top cell, top row. We need to write that as a single power, and therefore we need to simplify. So, this one might not be as automatic for us, but I'm hoping through all of our time that we spent reducing fractions and talking about how we reduce fractions by dividing out common factors, we should be able to see that I could divide a 2 out of the top and the bottom. But I could also divide another factor of 2 out of the top and the bottom. And divide another factor of 2 out of the top and the bottom. Now I have no more division operation. All I'm left with is my 2 times 2 on top. And if I have to write that as a single power, 2 times 2 is 2 squared. There we go. Okay, I think we should be comfortable now to tackle the entire second row. So I want you to go through, fill in all 3 columns of that second row. Pause the video now. Okay, we're back. So I'm going to go through a little quicker on this one. Now, we calculate 3 to the 7th, so that's going to take a little bit of work. That's a calculator question. However, we might be able to tackle that one, maybe without a calculator. Like, we know that 3 to the 4th is 81. We've memorized that. So if I take 81 and I triple it, then that gets me up to 3 to the 5th. So if I triple 80, that's 240, and I triple 1, that's 3. So 243 is 3 to the 5th. And now if I went through and I tried to triple that, well, if I triple 200, then that's 600. If I triple 40, then that's another 120. So that's now a 600 and 120, 720. Triple 3, there's a 729. Nice, I'm starting to get there. Now I get all the way up to 3 to the 7th. Well, if I triple 7, then that's a 21. So if I triple 700, then that's a 2100. So I'm going to take 2100. Now I'm going to triple 20, so there's another 60. And I triple 9, that's a 27. Hey, we end up getting 2,187. Hey, without a calculator. I think you guys could do that. Some of you are going to go faster than what I just did. Some of you are looking at what I just did and saying, there's no way I could do that. Yeah, you can. We just got to practice it. But I totally get if we were pushing buttons on 3 to the 7th. Okay, now we take a look. We've got a 3 cubed. There is a 27. And if I was to take 2187, so 2,187, I divide it by 27, I'm dividing it by almost 30. So if I take like 2100 and I divide it by 27, by almost 30, then I'm looking at like 70 something. But I'm dividing by something a little smaller. So that means I'm getting, okay, I get that you guys are probably pushing buttons on this, but we should be able to at least estimate it, that it's got to be something a little bit bigger than 70. And if we were to make that calculation, then we should get down to an 81. Okay, maybe I can see why it's 81. Let's go through and let's expand. So on top, yikes, I need to have 7 3's all separated by multiply. So 1, 2, 3, 4, 5, 6, 7. Checks out. On the bottom, I need to have 3 3's separated by multiply. Now we know that to get the simplified form, I need to reduce what I have in the middle. That means I can divide top and bottom by 3. I can divide out another 3. I can divide out another 3. All the division is done now. All I am left with on top are 4 3's separated by multiply. And so we get 3 to the 4th. Okay, I'm hoping that just on those 2 rows, you could now go and do the same thing we did in the last table. If I see this, I know that I get that as an answer. So if I see 2 to the 5th divided by 2 cubed, I know the answer is 2 squared. If I see 3 to the 7th divided by 3 cubed, I know my answer is 3 to the 4th. Can we go directly to a simplified form? Okay, try to find the pattern. Fill in that last cell. Pause it now. Okay, we're back. And I think we're doing great if we got down to 5 to the 7th. So if we were able to do that, then let's sum up our rule. And if we were a little stumped by that one, then let's take a look and see, okay, can we now work backwards that when given the rule, we can see it fit into the table? What operation were we doing everywhere in the leftmost column? We were dividing. So we were dividing powers. And we already know that the whole key to this is powers with the same base. Well, what did we do to the exponent when we did that? We found out that we subtract the exponents. You take a look in the first column, jump all the way down to the last column, and you'll notice that we subtracted the exponents. And what do we know is always true? The base stays the same. There we go. Okay, so hopefully not too bad. And we can now add a second law of exponents, a second power law. Okay. Now we want to make sure that we're good with it. Okay, similar to before. Now you see 5 questions on the screen, and I want you to go as fast as you can go. Like, I mean rapid fire. Okay? Go through and get an answer to all 5 as fast as you can. Pause it now. Okay, we're back. So we take a look at the first one, and I have a power 8 to the 10th divided by a power 8 cubed. I'm dividing powers of the same base. That means I subtract the exponents. Base stays the same. We should match up. Now, as I progress my way along, again, we're going fast as we can go. I'm going to bet and say that I would have an awful lot of this on your page. And I just want you to stop for a second. No, that's so wrong. And we just fell into a major trap. Remember, that trap is always, I deal with every problem like the last way I saw one. Stop. Take a look at what we have as our operation between those 2 powers. It's not division. I'm multiplying powers there. I just fell into that trap. So my first look is, okay, I have powers of the same base. Yes. My second look then is, what is the operation between them? Hey, I'm multiplying powers of the same base. And we know that if we are multiplying powers of the same base, we add those exponents. So I'm going to bet and say that I caught a few people on that one. That one was just one to get you guys to slow down a little, and I know I told you to go fast, but slow down a little and make sure that our recognition is always in the correct spot. What are we looking for? Okay, question C, we're back to dividing. Dividing powers of the same base, subtract the exponents, base stays the same. We're dividing powers of the same base, so we subtract those exponents, base stays the same. Again, like before, make sure you have brackets around your base on B and D, otherwise you are incorrect. And we're back with our good old omega, just to prove that it doesn't matter what the base is. As long as it is the same, then when we divide powers of the same base, we subtract the exponents, base stays the same. There we go. Okay, hopefully we match up. We are all good. And now we're about to move into our last power law for today. Okay, I'd like you to take a look now at the chart for number 5. This chart looks very familiar by now, and we should be pretty automatic to be able to go through, to the point where I actually want you to go through and deal with the entire top row all in one go. So we are going to evaluate, we're going to write it in expanded form, and we are going to simplify it. And I want you to take a shot on the entire top row. Okay, pause it now. Okay, so we're back. So on that first row in that first column, we have to evaluate 2 to the 4th all squared. So that means that I'm going to calculate that. Oops. 2 to the 4th is 16, so I need to calculate 16 squared. And maybe we remember what 16 squared is, or maybe we calculated that. I would be okay. We should get to 256. Okay, now we have to write it in expanded form. Well, what that says then is I would have 2 written down 4 times. That's all squared. However, you'll notice that I still have an exponent in that expression. So it's not really written down in expanded form. It was the inside power that has only been expanded. So what that means then is I need to, and I'm just going to clean up that last 2. Now square that whole thing. So I need 2 of those big ugly bases attached by multiply. Okay, now I need to write that as a single power. And when you look at that red expression expanded, we notice those brackets that I put around everything, they don't matter because it's all multiply. So what do I have? I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 2s, so I have 2 separated by multiply 8 times. There we go. So hopefully we match up. And if there was any hiccup, maybe it was a format. But now we see how we can fill in the top row. I think we should all be good to fill in that second row. So I want you to go ahead, fill in the second row, pause it now. Okay, we're back. So we should be able to tackle this same thing. So I've got a 3 squared, that's a 9. Now I need 9 cubed. Well, I know 9 squared is 81, and that's the highest power I need to know of 9. But if I was to take my 81 and multiply it by another 9, I need to take 80 and multiply it by 9, so that's 720, and then 1 multiplied by 9, 729, 729. And there is that expression evaluated. We're good on the expanded then. That means that I need to have a 3 times 3, that's all cubed. But now that means take 3 of those bases and make sure that those are separated by multiply. Again, we notice that those outside brackets or all those brackets don't really matter. It's all multiply. So what do we have? Well, we have this 3 that's separated by multiply, and we have 6 of them. And there we go. So same thing as what we did before. We should be able to go from the original expression and figure out what is the pattern that takes us to the end. So I want us to pause it now and try to come up with that pattern. Okay, we're back. And so I'm hoping that we got down to, without expanding that thing, that expression. So if we got down to 5 to the exponent 20, then we've got our pattern. So let's just make sure that we nail down the language to that pattern. Okay, what did we see? Well, what we had in that left column this time was something a little different. What we notice is on the inside of the brackets, we have a power. But that power has been raised to another exponent. So what do we have? A power that was raised to an exponent. So when a power is raised to an exponent, well, what operation did we do? Well, we may have noticed that we multiply the exponents, and we should all be good with the end. Base stays the same, and we're good. And there we go, and there is our third law of exponents. Okay, same thing as previous. Let's drill it in. I want you to go as fast as you can go. So what you see on the screen then, there are 5 more expressions. I want you to go as fast as you can and simplify each of those expressions. Okay, pause it now. Yeah, okay, we're back. So we take a peek at the first one. I have a power raised to another exponent. That means that I multiply my exponents. Base stays the same. And we should be good with when we need brackets or don't need brackets. So my base is -2. It doesn't change. I have an exponent 5, all raised to another exponent 7. There we go. It doesn't matter whether that base happens to be a variable. M to the exponent 72. It's becoming huge. Doesn't matter whether it's a fraction, and we're all good with the brackets around the 1/2. All to the exponent 15. And it doesn't matter if it's just some weird symbol like omega. And there we go. So hopefully we match up with all of our final expressions and we are good. And the only thing left to do is to make sure that we can kind of sum everything up for today. So what you see on your screen right now is just these laws of exponents written down in algebraic terms. So what we need to do is we need to take what we just examined with numerical examples, situations where we had numbers in certain places, and we need to make it generic. If we can acknowledge that these laws of exponents or rules are generic, they would apply regardless what type of number we have, then what we need to do is to make it more general. And what you'll notice on the screen then is I have put in no constants. There are no numbers in any of those positions. So there's nothing that then says, oh, but this law only works if an exponent is 2 or if a base is 5 or so on and so on. So let's take a look at the first one. And I'm just calling it first because it's the first one that we addressed. And again, there is no hierarchy here. The first one we addressed was if we were multiplying powers. We take a look at that expression that we've been given and we notice it matches our criteria. We are multiplying powers and we notice the bases are the same. They're both represented with an A. Well, then what do we do with those exponents? We add them. Base stays the same, and so our base is still A. Now, we should also notice that addition has a commutative property to it. And what that means is we may have also written this because it never matters what order we add in. And so either of those expressions would represent that property. Okay, I want you to try to tackle the second one then. So now we're going to jump into dividing powers. Can you write an expression that would represent the law of exponents? If we had a to the exponent m divided by a to the exponent n, what would that equal? Okay, pause it now. Okay, we should be back. And I'm hoping that we said, hey, if I'm dividing powers of the same base, then I subtract my exponents. Base stays the same. We should also note that that does not equal a to the exponent n minus m. I can't subtract my exponents in the other order because it does matter what order I subtract in. Right? 3 minus 2 is different than 2 minus 3. So make sure that we do not have an alternate form for that one. Okay, and now we're going to tackle the last one. Power to a power. So I want you to pause it, come up with an expression in the end. Okay, and we're back. And so we should have an a, because the base never changes, to an exponent of m times n. And you could just write that as mn if you wish, because we know if we don't see an operation, that means multiply. But we could have also had n times m as our exponent, because it doesn't matter what order we multiply. Okay, there is a formal set of statements that represent our laws of exponents. So we are not going to memorize a to the m times a to the n equals a to the m plus n. No. What we know is if we're multiplying powers of the same base, then we add the exponents, base stays the same. If we divide powers of the same base, then we subtract the exponents, base stays the same. And if we have a power raised to another exponent, then we multiply the exponents, base stays the same. Okay, here is a very, very, very quick practice quiz. Okay, what you see on your screen right now is everything jumbled up. I want you to try to go as fast as you can go. Push yourself a little bit. Come up with answers to those 6, and I think that should give you good, quick feedback. Have you picked up your laws of exponents for today? Do not use your notes. That's copying. That doesn't mean we know. If we can do it without our notes, that means we know. Okay, give it a shot. Pause the video now. Okay, we're back. So I'm just going to shrink that down a little bit to give myself a little bit more room to write in now. And it should just be confirmation for us. So let's take a look at A. A, I am multiplying powers. They both have the same base, so I know I add my exponents, base stays the same. In question B, I'm now dividing powers of the same base. So I subtract those exponents, base stays the same. Make sure you have your brackets around -7 or you are incorrect. Question C might have caused you a little bit of a snag. I am hoping that we recognize that we are multiplying powers of the same base. It just so happens we have 3 powers. Base stays the same, and we add the exponents. I'm hoping we have 6. Remember, if we don't see an exponent, we know that really means that there's an exponent 1 there. That's why we can get our exponent of 6 in our final expression. Question D, we have a power raised to another exponent, so I know that I multiply those exponents. Base stays the same. On E, I'm back to multiplying powers of the same base, so I add those exponents, base stays the same. And on F, I am dividing powers of the same base, so I subtract those exponents, base stays the same. And there we go. So I think if we were able to tackle those 6, then we've got it at least in the short term. Your job is to try to make that long-term understanding. So your job is to jump in and get as much practice so that when we come into our next lesson, we have our 3 laws of exponents and they are automatic. Automatic. If you can come into our next lesson with that, then you've got everything you need for today. So jump in and get as much practice as you can to get that done. Okay, best of luck.